Okay, so this was the problem that I gave you on Friday. It's going to be just like the problem on your 50-point test. So we're going to work through it and make sure that you understand how to do everything. Okay? So, number of solutions. How many solutions does this thing have? 4. Very good. The highest exponent is how many solutions he's going to give you. Alright? Then it's going to ask you to list the possible rational roots. Okay? So we know that is plus or minus P over Q. Plus or minus. The last, that's P, the last are on top, and the first are on the bottom. Q is the leading coefficient. So it is going to be plus or minus all the factors of 18. 1 and 18. Are y'all okay? Okay. 2 and 9. 3 and 6. 4 and nothing. 5 and nothing. Over the factors of 2 are 1 and 2. Remember what I have said repeatedly. If you write it like this in that blank, I will not give you credit for it. I will take all your points away for that portion. Okay? So you have to put everything over 1, which will be all those numbers. So plus or minus 1, 2, 3, 6, 9, and 18. And then you have to put all those numbers over 2. So that will be 1/2. 2/2 is 1. I've already got it. 3/2. 6/2. You already got it. 9/2. You need to write that one down. 18/2. That's 9. So those are them. Okay, the next thing that you're going to have to find on that test is Descartes' rule of signs. Plus, minus, and I. Okay? Now, how do I find the number of positive roots? That's right. So I'm going to look at this function, f of x, and I'm going to count the sign changes. So positive to positive, no. To negative 1. So it's just 1, isn't it? All right. Now, can I take 2 from 1? So it's just 1. Okay, can I change it to a 0? No, it's just 1. You can't do anything else to it, guys. It's just 1. Pardon me. The number of negative roots pardon me, is the number of sign changes in f of negative x. Okay? So, remember what changes signs are the odd exponents will change the sign of the coefficient. So this is an even exponent, he'll keep his sign. 3 is an odd exponent, so I'll change his sign. 2 is an even exponent, so I'll keep his sign. 1 is an odd exponent, so I'll change his sign. He doesn't have an x, people. You can't change his sign. So now we'll count these. 1, 2, 3. Okay? So there's 3. Can I do anything to it? Yeah. You always subtract 2 until you can't subtract 2 anymore. What's 3 minus 2? 1. Can I take 2 from 1? No, so I'll leave it alone. Alright. And then you got to make everybody in this column has to be matched up with everybody in this column, right? So 1's already matched with 3. Who's he not matched with? 1. So I'll just write him there. 1 and 1. Every row has to total this 4 right here. So 1 and 3 make 4. How many imaginaries? 1 and 1 make 2. So how many imaginaries? Okay? Now, we're going to start trying to find the zeros and the factors. Alright, so what did I tell you to do first? Yeah, what do I do first? Start finding the zeros. Do I just start guessing numbers? Yeah, always do f of 1 and f of negative 1. because they're easy ones to find. F of 1 simply takes the coefficients of the polynomial and collects them all together. So that will be 2 plus 7 minus 4 minus 27 minus 18. And right there my brain's going, I'm not thinking this is going to work. Okay? So 4 and 18 make 22, 22 and 27, negative 49. 2 and 7 make 9. 9 minus 49 is not 0, negative 40. So 1's not 1. Now we're going to try negative 1. Now, negative 1, y'all really, if you have your f of negative x written down, it is those coefficients, right? Because it's the same thing. It's the coefficient of the odd exponent will change signs. So 2, this will become a negative 7. This will stay a negative 4. This will become a positive 27. And this will stay a negative 18. Alright, let's see. Negative 4 and negative 18 make negative 22. And negative 22 and negative 7 make negative 29. Hey, what's 2 and 27? What's 29 minus 29? 0. So there's my first 0. Okay, so I'll write him down here. He is a 0. What's his factor going to be? X plus 1. Very good. So now what am I going to do? Yeah, now I'm going to use that negative 1 in synthetic division, and I'm going to get this 4th degree down to a 3rd degree. Okay? So 2, 7, negative 4, negative 27, negative 18. Where? Right here. Don't use that. Be careful with that. Alright? So bring down my 2, multiply, add, multiply, add, multiply, add, multiply, and add. So here's my 3rd degree equation. 2x to the 3rd plus 5x squared minus 9x minus 18. I would look and see if I maybe could group factor it or something like that. It certainly would make your life a lot easier. I'm going to say most of the time probably it's not going to work. It doesn't work here. Okay, so now what do? I don't have a calculator, so now I'm just like, you're just guessing, people. I mean, that's it. You're just guessing. You can guess whatever you want to. I'm just going to say this, that Wednesday when we take the test, some people will be lucky and they'll finish their problem in about 15 minutes. Some people will be not quite that lucky, and they may take 25 minutes. Some people will be not so lucky at all and have bad math habits, and they'll have tried the right one but accidentally made a careless error, and then it didn't work for them. You see what I'm saying? And they'll be working all period long. So you have to be really careful because it has a lot of room to make careless mistakes. Okay? So you're just guessing now. Really, we don't have any, I mean, we're not.
What class is next to us? I mean, like, just everything.
We are, if you had a calculator, you would know what to guess, right? You plug it in your calculator, see where it crosses the x-axis, and you'd be good. But I'm testing you without a calculator, okay? So, you're just guessing. What do you want to guess, guys? Negative 3. Okay? So, I'm going to use these numbers. 2, 5, negative 9, negative 18. Because I'm trying to take this cubic down to a quadratic where it will either factor or I should use the quadratic formula on it. So, bring down 2, there's negative 6, negative 1, 3, 6, and 18. So, negative 3 does work. Okay? So, negative 3, and what's my factor? X plus 3. Alright? Then I'm left with this 2x squared, okay? This 2x squared minus x minus 6. So I'm going to factor it. 2x squared factors into 2x and x. A minus sign means one's a plus and one's a minus. I'm trying to make a 1. So I'm going to use a 2 and a 3, and I'm going to make a 4 and a 3. I'm going to put my 2 here, make a negative 4, put my 3 there. Negative 4 and positive 3 make negative 1. So those are my other two factors, 2x plus 3, and then x minus 2. Now here's the deal, guys. Some of y'all might have chosen 2 next. Would it have worked for you? Yes, it would have. Yours down here would be different. Yours would have had 2x squared plus 9x plus 9. Okay, and then you would have factored it, and it would have given you these two factors right here. Okay, so this is a negative 3 halves, and this is a positive 2. Now, what's the last thing we have to do? Yeah, the last thing you have to do is graph it. And to me, when I have given my Algebra 2, my PreAP Algebra 2 kids, they've had tests just like this, but they did not have to graph. I have to say that graphing it is probably one of the most difficult things, okay? And not that it's like, oh my gosh, calculus or something. It's not. It's just you're probably going to have to play with some numbers that aren't very nice. Okay, so you are going to have to show your work and support your graph with a T-chart. I would say this. The first thing I'm going to do is graph my zeros. Negative 1, negative 3, negative 1.5, and 2. Now, let's talk about it. Somebody tell me what's, let me see. Let me see if I can remember it. I don't know. 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18. Is that right? Oh, very good. Okay. So, first thing I do is I look at my polynomial and I say, hey, you're a 4th degree polynomial, so that's even. What does that tell me about its end behavior? They're both the same. Okay, his leading coefficient is positive, so they're both going where? Up. Okay? Now, the next thing that I want is, guys, look, I just want 1 point in between all of these zeros. Okay? I know this thing is going to come down here, but I don't know how far down. He's going to come back up. He's probably going to go up here, come down here, and go back up. But I need to know, at least some kind of reasonable thing. So, first thing, let's go between negative 3 and this negative 1.5. Y'all, what would it be wise to choose? Yeah, I'm just going to pick negative 2. I'm not trying to find the min or the max, okay? I would need a calculator to find that. So I'm going to make it easy on myself. The teacher said she wanted a point. She didn't say, you have to pick the x that's right in between those two right there. She said, hey, people, pick a point, okay? So I'm going to pick negative 2. And then all I have to do is plug it back in right here, okay? So it's 2 times negative 2 to the 4th plus 7 times negative 2 to the 3rd minus 4 times negative 2 squared minus 27 times negative 2 minus 18. Okay, let's see what happens. What's a negative number to an even power? Positive, right? So what's 2 to the 4th? 16 times 2? All right. A negative number to an odd power is negative, and a negative times positive is a negative. What's 2 to the 3rd? What's 8 times 7? All right, what's negative 2 squared? What's 4 times negative 4? Negative times a negative is a positive, and 2 27s is 54. And then minus 18. Okay, so most of the time, I look and collect all my negatives and then my positives, and then I only subtract once. But I got some dang 50 stuff in there, okay? So my brain says, hey, why don't you just make your life a little easier? And what is negative 56 and positive 54? What's negative 2 and negative 18? Negative 20 and negative 16. Negative 36. So I got 32 minus 36. Y'all agree with me? Okay. All right. What is 32 minus 36? Negative 4. So at negative 2, oh, dadgummit. At negative 2, it's negative 4. So go and plot that point.
Yeah.
Okay, so now, what are we going to pick in between here? Yeah, y'all, this is negative 1 and this is negative 1.5. Negative 1 1/4, that's what I want to pick. Now I'm going to use negative 5/4, and I'm going to tell you this, I'm not doing it, okay? Y'all can do it. You're in PreAP, PreCal. Most of you are 10th and 11th graders. One's not, all right? So you ought to be able to do fractions. Does everybody agree with that? I mean, I'll show you what's going to happen. 2 times negative 5/4 to the 4 plus 7 times negative 5/4 to the third minus 4 times negative 5/4 to the second minus 27 times negative 5/4 minus 18. Y'all, 5 to the 4th is 625. 4 to the 4th is 256. 5 to the 3rd is 125. 4 to the 3rd is 64. You see what I'm saying? Then you're just multiplying those numbers out. Is it a mess? Is it pretty and nice? No, it's not, people. But you ought to be able to handle it. I think you get 91 over 168. Is that right? Did anybody do it? That's so sad. That's very disappointing. Okay? Nobody did it. I think that's what it is. 91 over 168. So let me show you what I'm going to do with that 91 over 168. What's half of 168? 84? I think it's 128. Sorry, not 168. So it's 64. Is 91 over 128 bigger than a half or smaller than a half? Bigger. You see what my brain just did? I said half of 128 is 64. This is bigger than 64, people, so this is bigger than a half. Is it more than 1? No. Is the space between 1/2 and 1 really small? Then put you a fat dot right there. Okay? I mean, please. Come on. All right, so it goes up to there. Huh?
Do we have to put it in T-chart?
Yep. Got to put it in the T-chart. If you don't put it in the T-chart, Kane, I'm going to count a point off, and you made a 49 out of 50, and that's pretty good. Did you deserve a 50 out of 50? No, because you didn't think it was necessary to do all of this hard 6th grade math and get me my answer. Okay? So, you'll just deal with your 49 out of 50. You don't have to put the zeros because I know you got them from that blank. Okay? The next thing, I have to pick a number in between here and here. Y'all, what am I going to pick? 0. And what does it give you? Negative 18. Okay? Right there. Now, here's what I'm going to do. Because mine doesn't go down to negative 18, I'm going to go down here below where it is, and I'm going to say, hey, there you go, Miss Davis. That point right there is 0, negative 18. And I'm going to bring my graph down to it, hit it, and go right back up again. And that's a good sketch of my graph. Anybody got a question? No? Everybody okay? Do you want me to give you one more to practice?
Yes.
Okay.
Yes, yes.
Here's your next one to practice. I'm not going to do this one for you. All right? You can use a calculator and check them off. I just wanted to make sure that I had worked one completely so you knew what I expected out of you. All right, so you can find all those things. Number of solutions, possible rational roots, Descartes' rule of signs, zeros, factors, and graphs. Dallin?
Are they all going to be that crazy like that one in school?
Yeah, I'm going to say they're all probably going to have one fraction in them that's going to say, do you want a 50 out of 50? Are you okay with a 49? Some people were going to say, it's one problem, like that right there. Okay?
Are there going to be like any bonuses on it?
Nope, no bonuses.
Wait, so just one thing?
I just don't know where you got that fraction.
We have a whole class to do it?
Uh-huh. Where I got what fraction?
I don't know if you got 91 or 1.
Oh, I got it because someone told me what it was.
Only have two special.
Oh, I'm sorry.
Two classes on Wednesday.
Okay, so you're talking about this fraction right here?
Yeah, I just don't even know, like, the next
Okay, I just took, okay, then, oh, I picked a number in between. This is -1 and this is -1.5. So in between -1 and -1.5 is -1 1/4. So I just picked a number, okay? I just made sure it was in there. But then I converted it back to an improper fraction because to me that's easier to do. Look, some people, Becky would have said, oh, that's -1.25. Do I want to raise -1.25 to the 4th power? No way. No way, I'm not doing it, okay? So this one's so much easier to do it this way. All right, anybody got a question? Okay, so that's your test on Wednesday. All right, so let's talk about the next section. Look, y'all, I feel like I have to apologize for, I don't know. I feel like we should be ready for a test, and if not ready for a test by Tuesday or Wednesday, well, especially Wednesday, we certainly should be ready for a test on Thursday or Friday. But whenever we have class, don't have class, have class, don't have class, have class, don't have class, don't have class, have class, I'm like going, I don't even know what we did. But that's the way they are. Because we're not, I mean, as far as all of my pre-cal classes, I won't see them Tuesday and Thursday. Not everybody. Okay? And then next week, what? I won't see you Tuesday and Wednesday. Because that's the TSI test. That's where they moved the TSI test. So see, they're killing me with that stuff. It didn't hit at a good time, is what I'm trying to say.
And they changed it right before, like, everybody already had their plans for the test.
We did, and that wasn't their fault. They couldn't help that. But it's just not hit us at a good time. So I kind of feel like we're dragging some stuff out, but I think we'll be okay. I think we'll be okay. All right, so we do need to do 2.4. We're not going to get very far with 2.4, but we're going to start on it. All right? Yes. So it is complex numbers. Man, I don't know what it is about. It seems like it's, maybe it's me. It's just in my pocket, but I think the last time I had it back here, it seemed to mess it up. Okay. No, he didn't. Okay, you covered complex numbers in Algebra 2, so you should know how to do this, but we're going to go all over it again. All right? So tell me what a complex number is. What are we talking about? What do you call them in Algebra 2? Imaginary numbers. Okay? We call them complex numbers a lot in Algebra 2 because I know after Algebra 2 you call them complex numbers. So I try to use that a lot. So why do we have them? Well, what if I had a problem like this? Looks like an easy equation, doesn't it? So let's solve it. Tell me what to do. Subtract 4 from both sides. So now I get x squared is equal to negative 4. Now what am I supposed to do? Square root. Now if you were in Algebra 1, what'd you say right here? You can't do that. Because you can't what? Take the square root of a negative number. Okay? But then you learned in Algebra 2 that they discovered a whole set of numbers called the complex numbers that address this situation right here. Alright? So, we're going to talk about them, and we're going to classify them. So, the negative under the radical is what the complex numbers are taking care of. So, the very first one is the square root of negative 1. What do we call the square root of negative 1? I. Okay? Square root of negative 1. Hey, Dallin. Thanks. The square root of negative 1 is I. Okay? Now, we're dividing these things up into two parts, guys. Okay? This to the left of the equal sign is not acceptable. If you leave anything that you see on the left-hand side of the equal sign in an answer blank, it will be automatically counted wrong. Okay? Everything on the right is acceptable. Okay? So, dang it. Okay. Because I can't use it because my microphone's plugged in. If my microphone's not plugged in, it won't record. Alright, so, I squared. Oh, stop changing colors. I squared. I squared. Here's what I squared looks like. It looks like the square root of negative 1 squared. What does that square do to that radical, guys? Yeah, it cancels it out. They're opposites. And so what's I squared equal to? Negative 1. The next one is I to the third. Well, let's see. I to the third is just I squared times I. Y'all agree? Dallin? I don't know. I'm just kind of sick of this. Do it again. Thank you. Nope. I don't know. Yeah, it kind of tried to, but it doesn't. Back arrow. Back arrow. Oh my gosh. And see, any other class I just go up to the front and do it, but y'all's class I gotta use the microphone. Everybody stand up and hold your leg up. No. I'm just playing. Okay, wait, I'm gonna turn it off and then turn it back on, and you're gonna make it smaller and then make it reconnect. Okay. Alright. So, I to the third is I squared times I. What's I squared? Negative 1 times I. Negative I. Okay? What about I to the fourth? Well, I to the fourth is I squared times I squared. What's I squared? What's negative 1 times negative 1? And then I to the fifth. Y'all, I to the fifth is I to the fourth times I. What's I to the fourth? 1. What's 1 times I? I. What's he doing now? He's repeating. I to the sixth is I to the 4th times I squared. That's 1 times negative 1. Negative 1. I to the 7th. Negative I. I to the 8th. 1. Okay? So what happens is these are the 4 that you have to know. Right? Okay. Anybody remember how we memorized them? No? Remember this? Yeah, that's exactly right. Okay, so here it is. It is. I won! I won! Keep your negative stuff on the inside, people. We don't want to see it. It's not pretty. Put your positive stuff on the outside. Okay? So this is the square root of negative 1. This is I squared. This is I to the 3rd. And this is I to the 4th. Okay? Alright, anybody got a question? Okay, so where are we going to use this thing? Well, what about this? Let's talk about the standard form of a complex number. Come on. Wait. Okay. I'm so tired of this. Okay. Alright. Standard form of a complex number. A plus BI. This A right here is the real part. BI is the imaginary part. Okay, so I think today we'll just do 2 things. We're going to add them and subtract them. Now listen, here's the deal. You're going to have part of the test with no calculator, part of the test with calculator. So I want to know, do you know how to add, subtract, multiply, and divide without your calculator? And then on the test, and then I'll have some on the test and you can use your calculator. Alright, so I'll show you both ways. The first one, example 1A, looks like this. 3 minus, oh, jeez, I'm going to have a heart attack. 3 minus I plus 2 plus 3I. Okay, so how do you add complex numbers? Guys, you treat the I just like a variable, okay? It's like you do in like terms. You're going to add the real parts, collect the real parts, and then you're going to collect the imaginary parts. So, a plus sign outside the parentheses, does it change anything? No. What's 3 and 2 make? What's negative I and positive 3I? Okay, so 5 plus 2I is our answer. Okay? Now, what if I wanted to do it on my calculator? Well, I just take my little calculator and I go, what? 3 minus I. Talon, just type it in for me. Okay? 3, oh, you got to, yeah, minus I. I is second in the decimal point. Close the parentheses, plus 2, open the parentheses, 2 plus 3I. And there's your 5 plus 2I. So, is it hard to do on the calculator? But if I only let you do it on the calculator, do I know that you know what you're doing? No, I don't know anything except that you know how to punch some buttons on a calculator. Okay? So that's why you're going to have to do it part with the calculator and part minus. Alright, so now let's do one that's a subtraction one. Alright, so this is 1B. It looks like this. 2I minus 4 plus 2I. All right? What's a minus sign outside parentheses mean? Yeah, distribute. Change the sign of everything in the parentheses. So 2i. What's the opposite of a positive 4? What's the opposite of a positive 2i? Okay? Now, who goes first, guys? The real number. So the negative 4. He doesn't have anything that you can add him to. Okay? And then what? 2i minus 2i? 0. So, now look, if you were taking, I don't care. Okay? I'm not going to count it wrong. But if you were taking an SAT test or an ACT test, and they said, find the answer and put it in standard form, are they going to have negative 4 as one of the answers? No, they're not. They're going to say negative 4 what? Plus 0i. Okay? Well, they might. I don't know. But anyway, so just know that the directions are probably going to say write it in standard form, but I'm not. If it's just negative 4 and you don't write plus 0i, I'm not going to count it wrong. Okay, Brent?
It probably sounds stupid.
No.
Can you, like, plot an imaginary number?
Yes, you can. You plot imaginary numbers get plotted on not an x and y axis, but a real and an imaginary axis. And it would be just like this, like watch. If I was going to plot 5 plus 2i, the real part is 5, so I go to the right 5, and then the imaginary part is positive 2, so I go up 2, and it'd be right here. Okay? If I was going to do 3 minus I, I'd go to the right 3 and down 1. Okay? But no, you can't plot them on a regular XY coordinate plane. Okay? Alright, so we'll finish it up tomorrow and see how far we get. No, we won't. Sorry, we're not meeting tomorrow. We're meeting, but we're not doing anything.